Welcome to our webinar about color control for digital printing, including high-quality spot color conversion with CoPrA and ZePrA. My name is Dietmar Fuchs, and I'm the product manager from ColorLogic. We are developers of high-end color management software based in Germany. And I'm here with Mike Strickler, who is a color consultant in the US, with whom we are working together to implement our technologies at the client side. Hi, Mike.
Good morning, Dietmar, and good evening to our friends in Europe, and I suppose good afternoon to our US friends on the East Coast, as well as to others around the country. Thanks for coming. I see a lot of familiar names in the list of attendees, and many of you that I don't know yet, particularly over in Europe. So thanks so much for being here. I've been working with digital print for probably 20 years and special multicolor projects in the last decade. I work fairly intensively with Crossix Color and ColorLogic, and it was an idea I had to share some of our accumulated knowledge about digital printing and the way we can improve your digital print workflow in terms of quality and efficiency.
Yes, indeed. For starting, I would just like to introduce a little bit of our products. We are mainly focusing on ZePrA, our color server, and CoPrA, our profiling application. But the full flavor of our applications consists as well out of ColorEnd. And basically, it starts with ColorEnd because you need test charts to characterize your printers. That's what you would do with ColorEnd. You measure and you optimize the measurement data, because only with good measurement data you can create good profiles. That's what we are doing then in CoPrA. And finally, we are applying those profiles in ZePrA, our color server. For ZePrA, that's our state-of-the-art automated color server that optimizes color for any output condition, output to digital presses that we are covering today. Just one example. It has advanced color management and spot color conversion functionality, with which the quality of the color conversion can be greatly improved. And if you consider all the tasks that are necessary for file preparation for the final printing, there can and should be a lot of things automated. And this improves consistency and reduces operation variation. With the color server in place, color control is centralized and works the same for any output. And certain tasks, such as vector objects, for example, can't easily be done otherwise than using a color server. At the end, at the bottom line, time and material is saved when you're using a color server. For CoPrA, that's probably the world's most advanced and versatile ICC profile creation software. We're creating output profiles with up to 15 channels. But not only output profiles, we are creating as well DeviceLink profiles. Input and output spaces can be gray, CMY, CMYK, RGB, multicolor, including ECG, extended color gamut printing. One very nice functionalities is our profile updating technology with reduced charts using spectral prediction technology. Device links we are using here with automatic and user selectable separation settings, and we can as well create safe ink profiles to save on ink. Mike.
So I get a lot of questions about where ZePrA and CoPrA fit into the workflow. Frequently I'm asked if ZePrA is a RIP. No, it is not a RIP. It is simply a standalone color conversion engine and application, and it can fit in any workflow. This would be a typical situation in a digital press workflow. Be a little bit different in conventional print. We have more pieces in such a workflow, but the principle is pretty much the same. So we have authoring or creation of some sort of artwork on the left, generally resulting in a PDF. But bear in mind that ZePrA can also convert images separately or within a PDF. So we have the formats right there: TIFF, Photoshop, JPEG, PSB, or large document format. It works. And then the file goes into ZePrA, and we perform our magic there and do the conversion, flattening, various things, normalization, conversion to target, and so on. And then out comes the converted document. And then it goes into your digital front end or your RIP for the normal operations like step and repeat, your imposition, all of that kind of stuff. The only difference is you notice that we bypass the color engine in the RIP. And we usually do this very simply by disabling color management, saying no profiles, something like that. Obviously, whatever baseline calibration is performed by the RIP of the press or the printer, it is still observed. We're still using that, but we are simply not using their color management. So linearization, if there are some basic ink limits imposed, by the RIP itself, then of course those are still imposed and all of that. So for operators, it really doesn't make any difference. They don't see any difference because they generally don't go into the color management settings anyway. And then the file is, resulting file or job is passed on to the digital press. There's one additional piece here, and it's very critical. Dietmar touched on it earlier, and that is the profile update. With electrographic presses in particular, that would be something like the HP Indigo with its liquid toners, or your powdered toner presses such as Xerox, Zycon, Ricoh, Canon, and so on. They can be a bit unstable. And we have a process that takes no more than about 5 or 6 minutes. And it's so easy to update that profile with current measurements that we can get back into operation right away. We don't have to do a full-on profiling and relinearization and this sort of thing. And so that is a tremendous boon to printers who work with presses like the HP Indigo and have color drifts and find themselves in a quandary over how to get back to the baseline color that was originally approved. So we've solved that completely, I feel. It has proven itself in production, and we use that small chart technology with spectral prediction model, and we can use extremely small charts. We'll show you that later. So why are we even talking about digital? Why don't we just talk about color management, and printing? And the reason I thought this presentation would be a good idea is that we do have a lot of people who struggle with digital print, particularly those who are conventional printers, perhaps flexo-label printers, who have acquired a digital press for some very clear advantages, their efficiency in short-run printing, and their higher cost per impression, but lower cost per job for smaller jobs. And they have trouble controlling the color. The reason is that it's very unlike, a digital press is very unlike a conventional press. It doesn't have any user controls for color, no ink keys, no impression adjustment. You can't adjust the damping or ink water balance. You can't, there's no pH solution to adjust as within an offset press. You can't change the cylinder packing, blanket packing, or anything like that. So it really looks sort of like a black box to the operator, and they end up getting into a lot of mischief trying to correct the color in a trial and error sort of way. In fact, the only color control on a digital press that really works is the color management of the input file. This is what a lot of people have trouble understanding, especially if they come from a more conventional a press background and they're not pre-press color specialists, for example. Also, it's a fixed ink set. Typically, a digital press has 4 to 7 colors, and they are fixed. There are some exceptions. For example, with an ErgoSoft RIP, you can switch out different color inks for special purposes. With an HP Indigo, you can order up a spot color, but by and large, I think one can say as a working assumption that these inks are fixed. So spot colors are not spot colors, they're simulations, they're builds. And for those who are printing brand colors, this is particularly a problem, where it's a difficulty because they can't go back to an ink room and make any adjustments. And finally, electrographic presses, toner-based presses can be quite unstable and ideally need to be reprofiled frequently, and yet the reprofiling procedure with normal tools can take an hour or more. So all of this results in a process that may be familiar to many of you. In the upper left, we see a customer a sample or concept. It could be anything from a previously printed job to a proof. It could just be a spot color swatch. And let's just talk about a spot color to keep this simple, because these are the most critical colors in digital print. I do realize that we have a lot of people aboard who may not be printing spot colors, and so just bear with us. We're focusing on this a bit today because this is such a problematic area for digital print, and with the increased popularity of digital presses for packaging and labeling, we thought it was something that we ought to focus on. So generally there is some suggested build. There may be a lookup table in the digital front end that one will access the starting numbers for, or simply let the press color management come up with a build and just print it. And then we see the arrow going into the press. We've chosen, in this case, a 5-color job. And then the job goes out to the press. We get a result. We see if it's okay. That's the bottom right, in case you're following along. And then we adjust the color accordingly. We send it back to the press. We try it again and again and again. If there are images, we need to break them out and adjust them in Photoshop. If there are vector elements that come out wrong that are, let's say, CMYK, not spot color, then we have to go back to something like Illustrator and click on those objects, select those objects, and adjust the color manually, and then print again and again and again. And this is, in a nutshell, the dilemma of the digital package or label printer, and that is iterative color correction on the press, using the press as a proofer. It's a very, very time-consuming and expensive process, and this is something that should be the first goal of any workflow improvement in digital print, eliminating this, okay?
So when it comes about conversion of colors, then we're talking about PDF. So PDF is really the container for all kind of printed matters. And in a PDF, there can be all sorts of color spaces inside. There can be all sorts of images, vector objects, spot color objects. An object can have an ICC profile assigned to it, which is then an ICC-based situation. And all this kind of colors need to be normalized first to a common output condition. Typically in an output, that would be an output intent in a PDFX environment. And from that normalized PDF, as it then is called, we would convert to the final printing condition. That could be an offset press, that could be an inkjet, that could be our digital press. And that's what ZePrA does. So it looks into all the files, it looks into spot colors, identifies the spot color. If there's an image, it looks if there's an ICC profile assigned to it, and then it converts it by using DeviceLink technology. And that's a very important part of getting to highest quality. We call that Smart Link. And why do we use Smart Links? Because with a DeviceLink profile, we get a much better quality than just using normal ICC profiles for the conversion. And we have a lot of nice functionalities here. And I would like to make a little break out here to CoPrA to just show you what the power of a DeviceLink profile is. So if we look into CoPrA, our profile application, we have different options here, and one is to create a DeviceLink profile. And let's assume we want to do a conversion from a Greco CMYK to our Indigo with 7 colors. So a DeviceLink is a fixed combination of 2 profiles, in this example, those 2 color spaces. And the beauty of a DeviceLink is that we can specify how the rendering should be, much more precise than if we have to go via the profile connection space via LRB. We can do it directly from CMYK to 7 colors. Obviously, we take the LRB information into account to get to the correct rendering, to the correct color, but we can do much more with that. One thing is, for example, we can preserve the separation or the black channel. And by doing that, we can avoid a lot of issues that can happen from when you do some conversions. For some multicolor conversions to from CMYK to multicolor, some people like to retain only the CMYK parts and do not use the extending colors and use the extending inks like orange, green, and violet only for the spot colors. This can be maintained or can be done as well in what we call the multicolor modes. You could use such a mode here, or you could use a lot of the multicolor colors to make the RGB images or even CMYK images really pop out by using more of the multicolor colors, still getting faithful reproduction of the original by doing that. And another very important functionality of a DeviceLink is that we can keep 100% black, 100% black. We do not convert it to 4 colors or 7 colors. We can keep the gray axis intact. So that means we still try to get a very good rendering of the gray, but it is still gray at the end. It's not contaminated with CMYK. The same can be done with primaries and secondary colors. Secondary colors can be colors like this that you can see here, 55, 30, 00 is a secondary color. We can simply keep those color characteristics intact and still do the conversion. And there are even more options, like, for example, triplex. And if you see all this, what is marked here in red, it means that we have an impact on how the conversion of such a CMYK, in our example, to multicolor is done. And that's the beauty of a DeviceLink, because what a digital media designer would do if he would convert, for example, a blend of gray colors or a blue blend in CMYK to another color process, he would like to retain that characteristics of the color and just mix the combinations a little bit to match the color on the final output. And that it can be done automatically with the help of a DeviceLink profile. And this nice functionalities here, if you would save this, you could save this and call them, for example, my settings, like this. And then you can even share this setting with ZePrA so that ZePrA can use your setting that you have defined to be used automatically when it creates those DeviceLinks on the fly by looking into the file and then seeing, okay, there's a CMYK object. I need to convert that to my 7 colors. I am using my settings in this example to get to that goal. And that's the beauty of a DeviceLink profile that we are creating on the fly with what we call Smart Link. I'm switching back to my presentation here, and those DeviceLinks are then created once and then cached for the next time. So if the next file uses a similar kind of conversion or has the same color spaces and these are combined, they will use those profiles will be used again, so that they don't need to be recalculated all the time. So speaking about image quality, there are other things that are important, and this Mike will tell you.
I just want to make a quick comment, Dietmar, on DeviceLinks. You know, from my position in the field, I see in packaging workflows, whether they're digital or conventional, a lot of reluctance to do any conversion of any objects, except sometimes images and always spot color objects. But if there are CMYK vector objects that may really need conversion to print optimally on a different substrate, for example, going from a coated to an uncoated or vice versa, or perhaps a substrate that has greatly different color, like an ivory color or bright bluish, which is going to shift the appearance of all the colors printed on top. these objects really do need to be converted. And I think it's because people are not fully aware of the ability of device links to keep colors pure and to optimize the separation, to preserve layers even in some cases. We can do that in ZePrA. So they tend not to convert when they really should. And I just want to mention that device links and Smart Link in particular is a great way to sort of overcome that inhibition and get a quality product at the end, a better product. Okay, so image quality. One of the things that I think is chronically overlooked in commercial printing is image quality. Images do matter. They sell products. Sometimes the product is the image. In the case of a calendar or a postcard or a poster, plates, color plates in books, image quality is extremely important. And yet I find it getting short shrift in many discussions. I suspect that in some cases that is driven by the limitations of the color management system being used. So in some cases also the physical output of the press is not so good. But it does matter, and I think we need to take a moment and pay attention to this. So on the left, we see an RGB test image, very, very colorful, with some gradient charts and so on. These are very sensitive tests, charts like this for color conversion. Colors can easily sort of be pushed out of place. You can get rough results if you don't have a really top-notch color conversion system. And the bedrock for that, for converting images, is a good profile. And CoPrA, as Dietmar mentioned, is the most advanced profiling software in the world. And I can substantiate that, having used pretty much all of them. Over here on the right, we can see some problems. This is a very popular system that was used to convert this image, and we can see at the top of the graph some roughness in the color gradients. We can see the same thing down at the bottom, and if we get really close, we can see some rather serious problems with this other system. So on the left, we can see that the background is a fairly smooth, sort of dirty blue gradient. And on the right, we begin to see, I don't know if you can point to that, Dietmar, but there's a kind of strange band on the left edge. And there's what looks to be a band around that large circular shape in the center to the left of it. So we have some definite artifacts there. The color gradient is rather coarse, it's blotchy looking. And then if we look down in the reflection area, we see that some of the details, like the buckle, the belt buckle on the lower right of the image, has just simply vanished. So that area has been completely blown out and posterized. Now, there are a lot of reasons why this can happen. There can be many flaws in a profile. I think, I have some suspicions. Part of it is that this particular system does not have a perceptual rendering table, so out of gamut colors may not be mapped very well. This is just a surmise on my part, but be that as it may, these systems are not alike. So pay attention to how your system produces images. Next slide, please. So there are some mechanical differences under the hood, some structural differences. CoPrA's by the way, that image was converted to 7 color. I should have mentioned this for printing on an indigo press. And we're going to dwell a little bit on multicolor just because it's such a stiff challenge for color management. If a system does multicolor well, you can be pretty sure they do a nice job in CMYK. So anyway, we have a CoPrA patch sample or a chart that we make the profiles from. This is for 7 color. It's a true multicolor system. All of the channels are full members of the family. You might say they can interact and overprint to get the smoothest result. We can restrict those things later in ZePrA, so we don't have problems from registration and things like that in conventional print. For digital print, that doesn't matter so much. The system on the right was created for a conventional print workflow with Flexo in particular in mind, and it has some very rigid rules about how colors can interact. So for example, you can see that orange can combine only with magenta, yellow, and black, and green only with cyan, yellow, and black, and so on. And there's a certain logic to this for certain kinds of printing. It's a bit limiting for digital print, and that may be part of the reason why it doesn't seem to do as good a job in images. The point is, these systems are not the same.
Okay, so we talk now a lot about device links and processing process colors and converting process colors from CMYK, for example, to multicolor, to 7 colors. Now we are touching on the subject of spot colors. And as Mike was mentioning at the beginning, if we're thinking on a digital press, well, you can't put a reflex blue in there or a Pantone red. So you have to use the inks of the digital press. And therefore, we need an ICC profile to characterize the printer. And that's what we have done. So we have created a color profile already. And now we want to convert some spot colors. And I have with me here a sample file, a packaging file for cat food here in this example. And if we are looking into the output preview, we are seeing it consists of an ISO-coded CMYK part, and it has 3 spot colors. The main 2 that we are interested in is the Pantone Reflex Blue and the Pantone Red that we want to convert to our output condition. And the die-cut line, well, we want to maintain that die-cut line because we need it later on for pre-processing, post-processing. So what do we need to do and how that works? I would like to show you in ZePrA. And therefore, I'm moving to the ZePrA application. And in ZePrA, we need to define the spot color libraries up front. So the libraries we want to use, that's the library in my example here that I want to use. By the way, you can load all sorts of input data here for spot colors. Yeah? So it could be a CXFX4 file with a lot of color information in for a spot color. You could load, if you have access or a license to Pantone Live, we have access to Pantone Live, so you get the information from Pantone Live inside here. You can get a lot of ways. There are a lot of ways to get spot colors inside in the system. And for example, here, if for this Pantone red color, we just have the full tone, and at least that's some information. It's not much, but it's the minimum information that we can get. And the more this information is spectrally available, like here, which we tell us always that is remission data, spectral data, the better it is, because the spectral data, we are using a spectral color prediction model to calculate the overprints. Because if we're talking about spot color conversion, it's not just that we have a full tone to match and to convert, but there might be interaction of the spot colors with process colors or with other process colors. And as they are converted, the overprints need to be predicted. And that's what we are doing with this model. And the more information we have, the better. Here we just have the full tone. For the Pantone Reflex Blue, it's already better. We have a full gradient and all in spectral information. And even better would be something like here, if we have not only the spectral information printed on a white background, but as well on a black background, because that without information, we can derive opacity information that we could use in our spectral prediction model to calculate the overprints. So the better the information you have and provide to the system, the better it can work. But it works already with only a limited amount of information. In this example here, just the full tone that we're just using here later on, and the gradient information. So once your spot colors are in place and the library is named, so that's the name of the library, I'm going back to my overview here. I have created already 2 queues for my indigo. One is using 7 colors, CMYK with orange, green, and violet. and the other one is the indigo with 7 colors. And in terms of the setting up of the system, here in the spot color tab, we would load the spot color libraries. In our example here, it is our spot colors X4 library. By the way, if there is a PDF in the PDF document, there would be CXF X4 information already available. Then ZePrA would catch this information and would use it, because that's obviously the best information we can get, because that's the spectral information available for each of the spot colors in the file. So we could use that information. If that is not available, then ZePrA looks into the next library that we set up. In our example here, our spot gradients library. And if another spot color is not in that library, it looks into the next library. And there's one where I defined the non-printing colors, the die cut, for example. It's just a color that we don't want to convert. And therefore, I just made up a library called non-printing colors, where I set up all those specific colors that I don't want to convert. And the beauty of ZePrA is that we have specific calculation methods for this spot color conversion. First of all, we want the best delta E, that's for sure. But it depends as well on our process. For example, for proofing, there we have an inkjet printer with high precision, and we don't care if a color build of a spot color converted to process color is using 4 or 5 inks. We don't care. We just want the best delta E. But for production printing, you probably don't want Pantone gray converted to 4 colors at the end, because that, well, can create unstable shifts in your color production. Or if there are some registration issues, well, that can be unsharp results from that. For production printing, we would use a method like use the least amount of channels possible, for example, and still trying to get to the lowest delta E. There are other methods here as well, but those are typically those models that we want to use, either for proofing, or the other 4 methods here are for production printing. We're using that method here. And now if we want to see if our sample document might be enough if you print it in CMYK, or do we need the 7 colors of the indigo? We have options for that, for checking that with our spot color report. Here in that dialog, I'm selecting the 2 configurations in questions for my indigo. I can select a PDF or an image file with my spot colors. That's my PDF document we just looked at. And I can, by the way, I can even load a library here with a complete Pantone library and check it, how that converts with those 2 configurations. But I want to do that just for my PDF. I click on preview, and then ZePrA does the calculation of the spot colors. And what it tells us here, if we look down, that's the configuration using a CMYK profile and the indigo with 4 colors, basically. We'll see if the delta E's here at the end, well, that's not good enough. So our spot color red and reflex blue will be rendered with those delta E's. So that's probably a no-go for the production. But using the same printer with 7 inks, with orange, green, and violet, we get very good delta E's for the red, 1.4 delta E, 2000, and nearly 0 for the blue, Pantone Reflex Blue. And here we even see the build that we are using. So we're using around 70% of magenta and 74% of orange. And here we're using 3 colors. We are using cyan, black, and violet at the end to get to that low delta E. And you see, we are not using a lot of inks, a lot of different inks, but the logical inks, what the previous operator would basically do himself as well, if he tries to match these colors in a way. And we try to get to the closest delta E by using this methodology. So we know we need that queue for our conversion. And the conversion itself is then very simply done by opening a folder here. So ZePrA uses hot folder technology, and you would simply throw in the original file, into the input folder, and then ZePrA would catch on that file and would convert the file. And Finally, it will do the spot color calculation. It will then do the conversion of the file, and this is then done. And we can check on the converted file. So I've done that conversion already. So during the processing, we can have a look at how that looks like. So that is my original PDF document with the 2 spot colors. And that is the converted one with the 7 colors. And as you're seeing here, we maintain the die cut line because we didn't want to convert that. But the 2 spot colors are now processed and converted by using green, orange, and violet. And you see it's not only the spot colors that we are converting, we are as well converting the images to get to a higher color vibrancy, let's say, and using those additional inks for our rendering of the colors. And by the way, you can check as well here on the full tone of the reflex blue, and we are seeing exactly those builds that we have seen up front in our spot color report functionality.
Okay, and just a couple of follow-ups here I'd like to make. Number one, people need to realize that if they don't already, and probably many of you do, that Acrobat cannot display these multicolor files color accurately. We do have some answers for that, and I'll go over that in a moment here. The other thing is that these spot color calculations are actually quite complex, and ZePrA takes into account printability, not just reducing the number of colors, but in some cases using some of the extra colors like an orange, a green, or a violet to stabilize the build. It's a complicated subject to get into here, but just keep in mind that it's not a simplistic calculation, and ZePrA is very, very powerful in the way in which it calculates these builds. So one of the things that has been added to ZePrA is the ability to make a proof off press. Now, this is not a rip, as I said, but what this does for a proofing rip is the same as what it would do for a digital press. We simply bypass the color conversion engine in the rip by disabling profiles. We do need an ICC profile for that printer and rip combination. So if it's a non-ICC system, we're going to need to capture an ICC profile. Or we can simply convert the document to something like Adobe RGB, which anybody can print. So we've added color bars. We can use third-party color bars or generate our own, and this includes multicolor. The reason we have this is that there are many rips and printer drivers that cannot make a multicolor proof, which is going to be essential if you're working with a web press. You don't want to stop the press, or even if it's a sheet-fed digital press, you don't want to be breaking into another production run to make a proof for the next job, let's say. That's sort of a deal breaker. That's really a problem. It's very common, but it's something we want to eliminate. So we want all that to happen upstream in pre-press. We want customer approvals outside the production area. We don't want customers in there proofing on the press and so on. So we have made a workflow that color manages these files up to pretty much any number of channels on the input, and then converting out to a proofer profile or some generally usable proofer input space like Adobe RGB or something like this that would have a large enough gamut to encompass all the colors. So that's a very, very nice new feature. It's been working very well. And you can verify, in some cases, still inline in your proofer if it has a verification tool that is suitable, particularly if it's CMYK. They all have this. Some of them don't need color management turned on for that. And the same with multicolor. We're beginning to see more multicolor verification tools. We can always use the compare tool in ColorAnt as well. Okay, next slide. Okay, so basically, Dietmar has sort of gone through this. The job has been set up. We've determined how many colors we're going to need for the job in that particular color configuration, or what some of you would call a strategy. and the job has been configured, and we can go ahead and we've updated the profile on the press. I'll show you that. I hope we have time to look at that in a moment. And then we submit the job, we get a report. It's really very straightforward. And we can also get this nice color accurate job preview, even for multicolor. So this sort of gets around the limitation of Acrobat, for example, to view a CMYK OGV PDF. Okay, and basically, in such a workflow, the only things you really need to decide once the job has been pre-flighted and so on, before converting, you need to decide what the material is you're printing on, because you'll have a specific configuration with an output profile for that. And how many colors, if it's a press that has multiple color configurations. If it's CMYK, it's always going to be this one at the top, 4 color, and that's all there is to it. Okay, next slide. So here we've got ZePrA running, and I'm going to leave that screen open. Now, one thing that hasn't been covered, you know, how we move these jobs in and out of folders, and what about automation? So ZePrA, like any other application or process, can be fully automated in Focus Switch or ESCO Automation Engine, Darlene Twist, things like that. Or you can simply do it manually with the hot folders. In automation, normally we would just set up a configuration to deliver jobs into hot folders, copy them to other folders, and so on. But there is a command line interface available. So for those who would like to sort of get around the hot folders and just sort of work directly with the application. So I'm just going to show you how efficient ZePrA is. What I've done is I've concatenated or connected a press process workflow. In this case, we'll go to a multicolor because that's the most challenging. And I've connected that with a proofing workflow, and those jobs are going to go into a proofing rip. So we get a hard proof getting spooled at the same time that we're, or immediately after we're getting a press separation. And it's pretty cool. So I'm just going to grab some jobs here. Yeah, I don't need that one. We'll just take these. I think that's good enough. And I'm just going to grab these from this holding folder. And that could be a folder where jobs come from pre-press, and you know they're ready for conversion. They may come from some other facility, but in any case, we're going to just drop it in. Here's a 7-color configuration. You see they immediately show up here in ZePrA, and we can sort of follow their progress. So all of these operations Dietmar's talked about, transparency, flattening, converting every single object in the PDF, spot, process colors, vectors, images, all of that is getting done right now in one click, one operation. And I must emphasize, this is key to ZePRA's productivity. It's able to take the entire PDF. You don't have to break out images and convert them in Photoshop and things like that. So we've removed all of the excuses that one might have for doing all of this manual disassembly and reassembly of documents. It's particularly important in digital print, which is supposed to be more efficient, to cut those fixed costs on the job and the added time for job prep and for color make ready. We want to get rid of that. If we take a look over here, we see job spooling. This is Fiery XF. It could be any RIP. And we've already got most of these jobs processed and ready to print. I'm not connected to a printer right here. But of course, if I did, I could just pick any of these jobs, select them, and say print, and there they are. I could also enable color verifying, depending on the RIP. So I could, in this case, because I don't have verification for 7-color in this RIP, I might set it to have input and output profile the same as the printer profile, turn on the verification, and have the print verified against the against the printer space. In other words, to see whether my proofing output has changed and whether it's still acceptable. And then I could use a third-party tool to go ahead and verify the accuracy as to 7 colors. Let's take a quick look at one of those files, those proofing files. Now, we can look at these because these are color managed. And I just want to take a look at this one. This is a very, very tough test form. Here's that RGB test image. Look at the smoothness of these. So this is an color accurate RGB view of the output of that system. And we see a tremendous amount of smoothness. We see all the gradients. And here's a label job from courtesy of my friends at Inland Packaging. It's for bottled water. So anyway, we have a color managed view here because it is CMYK. If we go in here to output preview, we will see a Canon CMYK proofer profile here. Okay, so there you have it. Soup to nuts. One drag and drop operation. We've got color managed press output of the highest quality plus a color managed proof. We could also send these files to an application like Remote Director, which can accept multicolor profiles and it can also accept RGB, of course. And then you can have a soft proofing.
Okay, thank you, Mike, for this nice presentation of the speed of ZePRA when it comes to color conversion. And now we are touching on the question that we just heard from one of the attendees who asked, why do we need to update a profile and not just simply relinearize the printer to get to the good result? And Mike, would you take over, please?
That's a really good question. In fact, it was a question I had about a decade ago when I first saw this. So the fact is that printer linearization, let's take a digital front end like that of the Indigo. In theory, yes, you should be able to just relinearize the primary ramps, and the overprinting should be consistent as long as the solid lab values also are readjusted. Then everything should come out the same. In practice, first of all, the tolerances are set rather wide for these presses, because if they were set too tight, the press would not be, quote, ready. You would not be able to print. It would say press not ready. So there's a certain wide variance that is wider than most people would like for the most critical printing. So that's the short answer. The fact is also, I find that even with these toner presses, particularly these toner presses, and certainly with other kinds of printing, overprints can change. When humidity changes, things like that, there actually can be a change in overprint. So the nice thing is that this is a 3D adjustment. It's not 2D, it's not just curves. We are adjusting pixel by pixel every single color. It's far more precise. I see we're coming up upon the hour. Let me go rather quick here. I'm not going to give a live demo of this, but we'll be happy to give that to you if you contact us. We can make an appointment and so on. So we have a very small chart, which spectral prediction model allows us to use as a proxy for the full size profiling chart of 2,000 or 3,000 patches, let's say. And we go ahead and we print and we measure this, and we do support a wide variety of instruments from Barbieri to the i1IO and many others. And then we get a result and we have to choose from a list. It tries to guess what profile we're trying to update, but we really do need to make sure it's the one we're trying to update, the one that workflow is based on. We select that. It gives us a percentage of accuracy. It's a little hard to see there. This one says, I think 79% or something. So anything below about 85, I usually like to do an update. 85, it's really quite good. And then I go ahead and I click next slide. And then I have set the naming template in CoPrA to simply add the extension _updated, so that when we save this, it just saves over the last quote update in ZePrA automatically, and we're ready to process this job. Okay, next slide. Okay, and then we get a report. It's very detailed. It has many pages. In fact, I've just shown the front pages, gives an overall result. Have we been able to really correct our color back to the baseline? And we look for, in individual patches and in categories, we look for a delta E of 0. Now, obviously, no press is able to produce with that sort of resolution or accuracy. We still have production variance, but what it says is that now we've reduced the variability to just whatever accuracy the press is capable of. You know, even from end to end, a form will not be completely uniform. There's nothing we can do about that, of course, but we can reduce the error to simple short-term press variability, and we can get back to baseline color. What this means is that we can reprint jobs with just this short procedure at the beginning of a job or as needed. For inkjet devices, it's needed much less often. And we can just do this procedure and get back to the way the job was printed the last time. And it will match end to end. It will be a dead ringer for the last time we printed it, and we'll be printing back to the profile's baseline. Okay, so putting it all together, we get a customer sample, we define the spot colors, we fiddle with the configuration, we decide on our spot color separation policy, we do have a profile for the press and that material. If we don't have it, we make it. And the master artwork, all of it gets converted. The spot colors go, you see in the center in that box, to a spot color conversion engine. The process colors, including images, of course, get converted through the profile. It all goes, in this case, through the chosen 7-color configuration that we determined we needed from that spot color report. And we just quickly update the press profile if needed, and we process the job. Okay. Finally, I want to mention, for those of you who have large printing operations with multiple art hubs or pre-press facilities or multiple production facilities, that there is a sync folder in ZePrA and CoPrA that coordinates and synchronizes settings across an unlimited number of ZePrA color servers. And so we can network, in effect, multiple ZePRAs. So when brand colors are added, all facilities get them. And everybody's ZePrA is, as long as we have it set to point to that folder, then that ZePrA will synchronize and get updated instantly. And that folder can be anywhere. It can be on your local LAN, or it can be out there on the internet, as long as you have an IT guy to point everybody there, and you've mapped that folder, all will be well. And so we have this ability in ZePrA, which is a little unusual, I think, and makes ZePrA a particularly suitable and very robust solution for large enterprises. Okay, so cost, that's what this is all about in the end. Even quality is a cost a consideration. We can charge a higher price for a better product, or at least keep the account, keep the customer happy. That's money in the bank. But waste, look at the waste. 30-minute setup time at $250 an hour. Is that typical? Yes, on new jobs that is typical with digital presses. It's quite typical. 7 minutes of running time, kind of typical. 18 cents per linear foot, that's quite typical for a 13-inch wide adhesive back label stock of good quality, like Avery. Total recovery per job, nearly $300 at 3,600 jobs a year. We've got a recovery for 2 presses of nearly $1 million. Now, this is why I tell people, just don't worry too much. I'm not saying don't worry about what these solutions cost, but some of our competitors have more expensive systems, but I never complain about that. I don't say get ours because we think we give you better value. Anything you can do to reduce your prep time and get a better quality product is going to be worth it. Okay, it's just going to be worth it. I like to say that Color Make Ready is the silent killer of printing companies. It's true in digital and it's true in conventional print. Because digital print isn't well understood, especially within conventional printing companies, it's a particular problem and results in a lot more waste than is necessary. And after all, these presses are supposed to be efficient. So let's keep them running all the time. Let's not take time down from production to be color testing. Keep those presses running. Do all of your prep upstream, a quick update of the press profile, and we're ready to run. And that's the whole idea here. It's a very efficient workflow. Okay. A little editorializing on my part. As somebody who consults in the field, customers typically ask for what they think is possible. If you tell them something's not possible, they won't ask for it. But your competitors might offer it. And then it becomes possible, and now you're judged as deficient. So try to keep up to date with your color management technology. It's a fast-changing landscape. Keep your tools up to date, whether they are tools from ColorLogic or some other provider, but please stay on top of this. And if there are any limitations, make sure that they're really necessary, okay? Check your tools. Never compromise a customer's color because your software can't handle the task. That should be a given, but I see a need to repeat this frequently. Realistic, brilliant color sells products, okay? It's very important when you're printing labels that those labels look as good as possible. It seems self-evident, but it should be said. Nearly all systems convert spot colors solids accurately. So the difference lies in tints, overprints, and printability. There are a lot of systems out there that convert spot colors solids, and they all do a good job. Everyone I've seen is doing a good job now, but that's not really the whole story. If we get a color that appears in a gradient, a letdown, a blend, and so on, in transparencies, those things have to be translated correctly, and only the most sophisticated tools can do that. Image quality is still important. Pay attention. And finally, a color server that cannot convert the whole PDF in one step, including RGB images, is a hindrance to productivity, and in my view, a profit killer. I'm going to be very opinionated about this, but I do think that ZePrA is just clearly superior to most of the other competitive solutions out there, if not all of them. It's really efficient in this way. Okay, Dietmar, would you like to say something in closing?
So thank you, Mike, for your elaboration. That's very helpful. It's very good because you're working in the field, you're working with clients, you're implementing the technology. We are just the deliverer of the technology, and there is a need of good people that understand how to put this all together. And Mike is definitely a guy to talk to when it comes to multicolor and all kinds of color management implementations. And as Mike was saying, yes, multicolor is a challenging field, but we have all the tools and they need to be implemented correctly. And there needs to be some help. You can't do that on your own. It's very good to have somebody who knows this already and can assist in doing that and getting you on the right way of doing that. And Mike is definitely a great person to assist here. You will find product information, download possibilities from the ColorLogic webpage. You might ask yourself, what is CrossXColor? That's as well an important aspect here. That's our US partner. So CrossXColor is our US partner located in Florida, and they take care of the US market. And they would be your contact persons as well in terms of questions, sales things, and so on. And they will then get you to the right consultant, such as Mike, for example, to get things done. So that would be my final words. Okay. Thank you very much for all the time and your contribution here. Mike, thank you again. That was very helpful and very illustrative. That's what you've told us. That's very good. Thank you.
Okay, and again, thank you, all of you. You're certainly welcome to contact me directly, particularly if you're in North America. And in Europe, Dietmar, they should be contacting ColorLogic directly, correct?
Yeah, we on our webpage, you'll find our partners in the respective countries, and they would be the first contact persons to get in touch with.
Okay, great. Okay, thank you, and stay safe, everybody. And we'll see you the next time. Thank you.
Yes, indeed. Thank you very much. Stay safe and have a good day.